guys, a very happy morning to one of you. And now we are just going to see that mainly, especially the problems only in the thermodynamics. So from the next few classes, the problems of thermodynamics only we are just going to discuss. So mostly it will be around 50 to 55 minutes, I suppose. So before going to each of the problem, we will have a 5 to 10 minutes of discussion of the previous year. It means not a previous year, about the things or the formulas that's been given. So after that, we'll just go and discuss the problems. Okay, I hope so you understood. So without wasting time, let us get started. Okay, let's start our class. Okay, welcome to my channel. My name is Rangaku. Let us get started. So thermodynamics basics and energy interaction, and heat dynamics means it's means power. So work divided by time. Okay, so next one, gamma is for monatomic gas 1.67, it's about noble gas. Gamma for diatomic gas 1.4, it's about H2O and O2 and this remaining thing. Gamma is 1.33, it is triatomic gas, it is O3. So universe, you can see system and boundary plus of surroundings. So system, it means quantity of matter under focus is system, and surroundings, everything external to the system is surroundings. Okay, the system may be real as well as imaginary. So closed system, no mass enters. Closed system, no mass enters, but energy interaction will be okay. No mass enters, but energy interaction will be, so it is closed system. So open system, mass and energy interaction will definitely be okay since it's open system. Isolated system means no mass, no energy. Okay. Suppose if it is insulated system. Isolated system means no mass and no energy. Insulated means no mass, no energy, but work interaction will take place. But isolated system, work interaction also won't take place. Okay. So control surface, control mass, and control property, character of the system. So extensive property depends on the mass of the system. Okay. So intensive property doesn't depend on the mass of the system. Okay. I think so you can understand. Extensive means depends on size, mass, volume, kinetic energy, potential energy, and enthalpy, entropy, and this kind of thing comes under extensive. Intensive means does not depend volume, temperature, pressure, density. It means radiation and diagram for things. Okay, whenever a thing is extensive by extensive, suppose if the word is given specific means it is comes under the idea of intensive properties. So the entire thermodynamics is only carrying of independent intensive properties. Don't, it means please do remember. It means the formulas, each and everything we do write upon intensive independent property. Intensive. Okay, I think so you understood. So state, you can see it means refers to the condition of a system. Process, it is said to be if a system moves from one equilibrium state to other equilibrium, that is called as process. So 1 meter cube is 10 power 3 liters. So path means series of equilibrium state that process which it means goes on. Okay, non-quadratic, quadratic, I think so you know. So non-quadratic means any kind of irreversibilities and non-uniformities like this kind of things comes under means it's non-quadratic. Okay, so next one is dash lines, throttling, adiabatic mixing, nuclear reaction, plastic deformation, heat transfer through finite temperature difference. Okay, so cyclic process, you can see system undergoes number of process but initial and final states are the same. Okay, so properties independent of the path followed, so it is called as property means state function and point function. Exact differential of a property is exactly equal to 0, so cyclic process. Next one is n equal to mass divided by molar mass. Okay, number of moles equal to mass divided by molar mass. What is n means? N is kilo means kilomoles. Okay, the unit of n is kilomole. So mass is kg and molar mass, you can see molar mass means it's one just code like this. Okay, kg per kilomole, that's it. Okay, so it means characteristics gas constant is equal to 8.314. okay, kilojoule per kilomole kelvin. Okay, I hope so you understood. So so next one is small r is r bar divided by m. Okay, small r, it means you can see where is that one. I'll just show you that. So you can see r, it is normal gas constant equation is r bar divided by m. So this is PV divided by, it means a compressed vector equal to PV divided by NT divided by f r bar. Okay, so here the pressure tends to 0. Okay, so next one, reduced property equal to P divided by PC, and reduced temperature is T divided by Tc. Okay, critical point is PR and T are equal to 1. Okay, I also you understood this one. So that equal to 1, that greater than, that less than 1. Okay, so next one is generalized compressive vector. So whenever the reduced pressure tends to be low, or whereas when the temperature is so much greater than equal to 2, it comes in the category of ideal gas equation. Okay, that equal to 1 irrespective of temperature, that equal to 1, other reduced pressure will be so much. Okay, so phase change is irrelevant. Okay, so you can see ideal gas z less than 1, z equal to 1, z greater than 1, and all comes under the category of real gas. but in that ideal gas that equal to 1 alone we consider. So you can see PR equal to 0 and TR greater than or equal to 2. So for this alone ideal gas we are just taking. So because in ideal gas we don't consider intermolecular force of attraction, okay, and volume of gas small compared to volume of container, okay. In this kind of two things we don't consider. P equal to N R bar of T. This is ideal gas equation. R depends on the molar mass is definitely and independent of temperature, okay. So P is specific volume equal to RT, okay. So P equal to rho RT open system. Absolute, as each and everything we take according to absolute temperature and absolute pressure. Absolute pressure equal to gauge pressure plus of atmospheric pressure, okay. Next one, molar mass of mixing equal to x1 bar. It means x1 bar is, this is mole fraction, okay, not mass fraction. X1 bar of M1 plus x2 bar of M2 plus x3 bar of M3. So R of mixing equal to, it means universal gas constant divided by M of mix, okay. X bar is mole fraction and X is mass fraction, okay. So x1 bar N1 divided by N1 is this one, okay. Mass fraction means M1 divided by M1 plus M2 plus M3, okay. Next one is molar mass, so we can also find by this, okay. 1 divided by x1 divided by M1 plus x2 divided by M2 plus x3 divided by M3, okay. I also understood. So molar mass of air is just 29 kg per kilomole and R of 0.287 kg per kilojoule per kg kilomole, okay. So nitrogen for 14, this one is okay. So next one van der Waals P A plus V the whole square. V minus of B equal to RT, okay. A divided by V square of course intermolecular force of attraction. B is volume of mole, okay. A is m power 5, okay. A is m power 5 kg per second square and B is m cube k means kilomole, okay. So next one is also important. In the critical point all of these three exist, okay. You can see dou P by dou V, pressure, volume, okay. So dou P by dou V of critical point equal to 0 and dou in square is also 0 and less than 0 means it's about 3, okay. A is 3 PCVC the whole square, B is VC divided by 3, okay. R equal to this one, it means for generally for which one? For van der Waals equation R equal to 8A divided by 9 VC of TC, okay. So compressively chart factor equal to 3 divided by 8 and generally 0.375, okay. Minimum that value, okay. Ideal gas, semi perfect gas and perfect gas, CP and CV are function of time and CP and CV are not function of time, and gamma, okay. I think so you got the point. So okay, so today we are just going to see the third chapter, the problem. So I'll just explain a little bit. So third first law is conservation of energy and concept of internal energy, closed system, cyclic process, and physics first law is change of heat interaction, okay. This is net interaction of heat interaction, okay, not only Q. Net interaction of heat interaction equal to net interaction of work interaction, okay. So Q is, if positive means it is power producing and Q is power consuming, okay. So heat interaction are generally path function, heat and work are path function, heat path function, inexact differential, energy in transit and boundary phenomena, okay. The energy of a system is property, and everything, okay. Change of energy is definitely equal to change of energy too. Energy is a property and energy is a point function, exact differential, independent of the path, okay. So energy we tell about the internal energy, okay. First of thermodynamics you will about this one, okay. So W equal to 1 to 2 P of dP, okay, in this entire thing. So cyclic process of change of energy E equal to 0. Whenever the point function means cyclic process entirely equal to 0. Change of property was cyclic equal to 0, okay. Purpose of motion machine for the first is definitely can't possible, because without any kind of heat supply there is impossible to or getting amount of certain amount of work, okay. Okay, so I think so now we can just see the questions. How much questions are there? Only 18 questions. So wow. So we can see it at very much quickly. So let us start. consider, I think so you are able to see this one. Just zoom a little bit. Now it's okay. Consider one mode of ideal gas in a closed system undergoes change in a state from L to U, okay? L to N, and 2, it means 1 is, this is volume, it means you can see divided by mole is given, so it is molars per volume, okay? So non-isothermal process 1 is carried out in a single step, namely LN, okay? Process 2 is carried out in this one, so all are reversible. The rate interaction of the heat Q1 and Q2, value of Q1 and Q2, okay? Net interaction of Q is net interaction of W, okay? So what is this is, since it is a triangle, we calculate this entire cycle. 1 by 2 P2 minus of P1 P2 minus of P1 equal to E of W. So 1 by 2 200 minus of 100 0.03 minus of 0.02 equal to E of W. So while you are calculating how much, what's the answer? 100 divided by 2 0 1 50 E of W. So kilopascal, okay? Into 10 power 3. So 50 into 1 into 10 power minus 2 into 10 power 3. 500, okay? B. 1 is P. Next is this one. A closed system contains 8 kg, okay? Mass equal to 8 kg. Undergoes expansion process. P power 1.2 equal to constant. Initial pressure 1 megapascal, okay? And final pressure is 1, okay? Graph is 1 megapascal, and let us suppose 5 megapascal is this. It may be like this also, like this only will be 5 kilopascal. B1 is 1 meter cube, so we don't know the V2. Specific internal energy, gas internal energy decreases, so minus 40 kilojoule per kg, okay? You can see it is given in the intrinsic properties, okay? So what is the Q? So Q equal to delta U plus of which one? Work done, okay? So you can see Q is in kilojoule. Delta U is, you can see delta U is in 40 kilojoule of kg, so we need in kilojoule. So 40 kilojoule per kg into 8 kg, okay? Kg cancel plus PV, it is polytropic process, so P1 V1 1.2 equal to P2 V2 1.2. So P1 is 1 into 10 power 3 Pascal, kilopascal. So P2 is 5 kilopascal equal to V2 by V1 1.2. So by this we can calculate the V2, okay? P1 V1 minus of P2 V2 divided by N minus of 1, okay? I think so you can understand. So directly you just calculate the answer, okay? Okay. Oh yes, and other thing is since internal energy is minus, okay, minus, that's also important. So you can easily calculate. So you can just go for third one. So you can see the statement. First, heat is a path function. Energy is a property. Energy of an isolated system is not conserved. But some motion of first is everything. So C is the right answer, okay? So you can see according to first law of thermodynamics, okay, for isolated system, Q equal to 0 and W equal to 0. So you can see energy of an isolated system is conserved. So it means isolated system means Q interaction 0, work interaction 0. So Q equal to delta U plus of W, 0, 0. So this one delta of it means U initial will be U final. So internal energy is been conserved, been stored in it. So that's why C is wrong. It means it's not conserved with okay. The first law of thermodynamics also known as conservation of energy. So you can see true with respect to no, they are not exact differential. They are path. Okay, 1 and 3. Okay, 1 and 3. So the first law of thermodynamics can be written as so generally delta Q equal to delta W plus of D E R D like this also will be given. Okay, so the option is A. So why dq will not come? So it's for differentiation. So differentiation can't come. Okay, guys. Okay. So just a cyclic integral of you can see work as well as the heat are path functions, and you can see dE it is point function. Suppose you can see if this has been changing means you can see we can just integrate and we can differentiate, we can calculate. But this kind of things is a little bit difficult. Okay, that's why it's called the path functions. Next you can see U is given. Okay, next is 7th one. So U is 3.5 PV plus of K. Gas expands to initial volume V1 0.25, V2 0.86, initial pressure. So P1 5 Newton per meter square. Okay. Wow. P2 is how much? So you can see 1 Newton per meter square. You can just go as it is, guys. So no need to conversion because you can see this is meter cube, this is meter cube. 1.3 P2 V2 1.3. So I calculate P2. Okay. And afterwards you can see P1 V1 will come. Okay. U equal to 3.5 P1 V1. So delta U is U2 minus of V1. So 3.5 P2 V2 plus of K minus of 3.5 P1 V1 plus of K. Okay, K is just a constant. K you just cancel the K and we will get the answer. Okay, you can see this one. So they just put it means just input here, that's it. So you can see what our answer is, what minus is coming. So internal energy in this process it's been decreasing. So next question. A system undergoes change from state 1 to 2 during the process of change in the internal energy U. The change in internal energy of a system, okay, 1 to, so definitely it will be equal to, you can see cycle 0. So this one you can just see 8th question, sorry 9th question. So initial volume B1 0.2, V2 is 0.1. So constant pressure for pressure equal to 3. Okay. So heat transfer, the heat transfer from the gas, okay, Q is about 50 kilojoule. Change in internal energy, so Q equal to W plus of dQ. Okay, so you can see whenever it means work input it is minus, so work output is positive, heat input is positive, heat output is negative. So minus of 50 kilojoule. If the integration of PdV is 3 V2 minus 0.1 minus of 0.2 of d. Okay, just put and we will get the answer. So what will be the answer? So this will be 3 bar. Okay, 3 bar means 30 kilo Pascal. Okay. This one 30 kilo Pascal. This one is meter cube. Okay, meter cube. Okay, so Newton per meter square. Meter square, this one cancel, this Newton meter comes, so joule. Okay, so now we put 30 means minus, now it becomes minus 50 and 3 minus 0.1. so since it's been coming, so if it comes this side means definitely it will be minus 20. Minus 20. So Q is a path function, W is a path function. Q is a path independent. Okay. It's been asked in 2030 chemical. Q is path independent, W is path dependent. So no, Q is path independent and W is also path independent. Okay, so you can see Q minus W is path independent. Okay, so next we can see heat and work are point path functions. So you can see this one. Q minus W is a point function, so point function is path independent. Okay, I think so everybody understand. So for this you can see this one. So point function is state function, depends on only state of a system. Okay, so point function are path independent. Okay, point functions path independent, yes, definitely. So just for the example, you can see it means 0 level, 0 meter to 1000 meter. So whatever you path you are going, altitude doesn't change. Okay, path functions you can see specific path. So for to reach the final state, Q and W are path dependent version. Okay, so to raise the temperature of water, you may heat it directly with the flame, or you may stir it vigorously. Okay, wow. So both routines reach the same final temperature, but the division of the energy between is work. Okay, as you said, I mentioned. So next you can see this one. Well insulated tank. Okay, well insulated tank. So then Q interaction equal to 0, work interaction will be 0. So only the internal change will occur. So R anyways Q equal to I square RT. Okay, let us see. So sorry, isolated system also, and isolated system only Q equal to 0, W equal to 0. So this one won't be equal to 0. Okay, the heat won't come outside. So Q will be definitely 0, A or D. Okay, so W equal to I square RT generally. 10 into 23. Time was joule per second. Okay. So wait, and in this time I'm a little bit confused. Okay, Okay. Work divided by time is, work is, okay. Wow, good. So you can see I square is 2300, so 2.3 kilowatt joule per second. Okay, just a basic thing only. So delta U is minus of 2.3 kilowatt. So answer is E. Okay. So in this electrical work is done on the system, not by the system. So that's why it is minus. So the internal result comes as positive. Okay, work is done on by the system is quite different. So I hope so you understood. Next one you can just see. Question number 13, 14. CP, it means molar. 5/2 of R bar. Okay. Adiabatic. Okay. P1 1 bar, T1 300 Kelvin to pressure P2. Okay, P2 we don't know the final temperature. T2 is 600 Kelvin. So the mechanical efficiency of a compression efficiency 50%. P2 is how much? Okay, then P1 V1 equal to P2 V2 power gamma. Okay, so P1 T1 P1 1 minus of gamma by gamma equal to T2 P2 1 minus of gamma by gamma. So we don't know gamma. Gamma equal to Cp by Cv. R Cp minus Cv equal to R. Okay, Cp minus of Cv equal to R bar. Cp is given, so 5/2 R bar minus of Cv equal to R bar. So let us suppose 5/2 R bar minus of R bar equal to Cv. So into 2, so 3 R bar divided by 2 equal to Cv. Put here 5/2 R bar, 3/2 R bar, 2 gets cancelled, so 5 divided by 3 1320.6 18, so 1.6 comma equal to 1.6. By this you can calculate the T2. The work required for the compression is P1 V1 minus of P2 V2 divided by gamma minus 1, or MR T1 minus of T2 divided by gamma minus 1, or N R bar T1 minus of T2 divided by gamma minus 1. So at the end put efficiency. That's it. I hope so you understood this one. See this one. Gamma value. Okay. So what is the gamma value? 5/3. Okay. Put here and we can just calculate the answer. So did I made any lot of mistakes? so somewhere I just made any kind of mistakes or just 1 second guys. T1P 1 minus gamma by gamma, okay. T1 V1 gamma minus 1 equal to T2 V2 gamma minus 1, okay. Pressure is a path independent, heat is a path dependent function. So okay, extensive energy I think so you are known. So for this one, two paths is showing, okay, one is reverse path. So exchange energy is same, okay. The answer is B. So this one I think so you can easily do it. This one you can see. So 18th gas contained in a cylinder, okay. Gas container is been compressed, okay, compressed. Work required, okay. Work done by the system, sorry, work done on the system work is minus 5000 kilojoule 52. Heat interaction, so heat been going out, so minus 2000 kilojoule. So the change in internal energy, okay, Q equal to W plus delta U, minus 2000 minus 5000 plus delta U will be 3000 plus of 3000, okay. Okay. Now we will be seeing some of the quite interesting process. So before that we will have 5 minutes of revision. So it means W equal to W of D, okay. It means electrical and shaft work. In this we just also consider state postulators. Simple compressive can be defined by two independent integer properties. So you can see this entire thing here, pressure is independent and temperature is changing, okay. So here dependent integer properties you can see, it means where it is on there, wait. So here you can see 7 to 8, okay. Pressure and temperature is, if pressure lightly change, temperature also lightly change, and you can see 8 to 9, pressure increases, temperature increases, so 10 to 11 both, okay. Here 10 to 11 you can see pressure and temperature is same, but specific volume rises so much. So single phase substance, water, liquid and superheated air, independent integer properties, and the temperature and specific volume and pressure and specific volume. So most of the equations comes and based upon temperature, specific volume and pressure and specific volume, okay. So next one, U, it means you can see internal energy is a function of temperature which is specific volume, okay. Here the entire thing internal energy is function of temperature and specific volume, and as well as the entropy also will go according to the temperature, pressure and specific volume, okay. So CV equal to dou U by dou T with respect to V, okay. I think so you can understand. So du equal to Cv of dt, okay. U equal to 122 Cv of dt. So you can see internal energy is a function of temperature only, okay. So Q0 W0, so Cv of del T, okay. Here this is molar, okay. Molar means kilojoule per mole will come. So molar specific heat of constant volume, okay. So mCv of del T is this one, okay. NCv dash bar of delta T. So any substance having Cv undergoing isothermal process, perfect gas undergoing any process. So next one, this one is for water with specific heat is about how much, 4.2 kilojoule per kg, okay. Next one is enthalpy H equal to U plus of PV. So specific means H equal to U plus of PV, it is specific. So specific enthalpy is equal to entropy divided by mass. So H equal to temperature with respect to the pressure. It means dependent integer properties, okay. Okay, so H equal to HT comma P, okay. Then dH equal to dou, it means this is just an expansion, so you just remember this one, dH equal to Cp of dt, okay. So enthalpy is also function of temperature only. Okay, so you can see PV can be M or T. Okay, so this one joule per. Okay, so isochronic process volume constant. Okay, Gordon 0, delta U equal to mCV of delta T Q. Okay, this one. So temperature increases, pressure increases, so shaft work. Okay, I square of RT plus of this one, it means work. This one will be the changing one. That's it. Okay, T of theta. T of theta is generally we do consider them as a work. So you can see electricity is always work done on the system. Electricity always work done on the system. So T of theta you can see 2 pi. Okay, generally the 360 degree angle. Isochronic process pressure constant dP equal to 0. So you can see dP 0 means we need to expand this one. So P dV that we need to expand, and we can see V of dP. Okay, so generally this V of dP 0. Okay, du plus dP of U. Okay, QH equal to dH. Okay, enthalpy is delta H. So delta H equal to mCp of delta T. Okay, for example, this Q will be represented as a delta H. Delta H equal to mCp of dt only for constant pressure. So Cp equal to this one. Okay, so Q equal to H of delta T. Okay, so okay, isoporic. Okay, this one I'll just explain. Cp R greater than C2. Cv is R of gamma T. Cp is R gamma of gamma by -1. Okay, gamma R gamma -1. So kinetic change of gases internal energy equal to F divided by 2 of RT. F divided by the degree of freedom divided by 2 of RT. F is degree of freedom, and Cv is F divided by 2 of R. Okay, F divided by 2 of R. Okay, and the Cp is F by 2 plus of 1. Okay, this one F divided by 2 of R. F divided by 2 plus of 1 of R. Okay, H is F by 2 plus 1 of RT. Okay, so dividing Cp by Cv, and gamma equal to 1 plus 2. 1 plus 2 divided by F. Okay, monatomic, diatomic, triatomic. Air is diatomic, monatomic is perfect gas. Okay, all monatomic, perfect. Diatomic, this one. So this one I think so around W by Q. So same temperature increase QP. This one. Okay, heat addition. Okay, so this one. Okay, isothermal temperature is constant. So generally you can see here the enthalpy will be, there won't be any change. Okay, because this is change of enthalpy, so it will be 0. Q of delta W. Heat supplied fully to displaced work. Okay, adiabatic process Q equal to 0. Okay, adiabatic expansion, temperature decreases, pressure decreases, and volume increases. Okay, polytropic process. Yes, you can see for this the Q will be W P1 V1 minus of P2 V2 N minus of 1. Okay, this one. So Q equal to, you can see gamma, what is the value of Q equal to gamma minus of N divided by gamma minus 1 of WD. Okay, gamma minus N divided by gamma minus 1 of WD. Okay, generally 1 less than N or less than gamma, so work done means W of D is positive, so WD is always greater than Q. Okay, so for example, you can see if heat is applied to 20,000 kilojoule, you can see change. It means we are getting 40,000 kilojoule. It means here the internal energy is also been decreasing. Okay, so what done? Okay, so W volume increases, delta U decrease, the temperature is definitely here the temperature will decrease, pressure also decrease. Okay, PV equal to C and PV. Okay, polytropic specific heat test. So in this you can see, so Q equal to gamma minus of N divided by N minus of 1 of WT. Okay, the same thing, polytropic specific heat, polytropic. Okay, so polytropic equal to same gamma minus of N divided by N gamma, it means gamma minus N 1. Okay, gamma minus N gamma minus 1. Okay, this one gamma minus N minus of 1 of Cv, constant volume. Okay, suppose if the given value is less than gamma and greater than 1 means the Cp of will be negative. Okay, if N greater than gamma, the Cp value will be positive. Okay, free expansion, okay, delta energy Q0 W0, energy will be constant. Free expansion P1 V1 equal to P2 of V2. So read carefully, okay, energy loss by system, okay, energy gain. It's okay. So I think so we can just start the problems. So for a single phase system, liquid and vapor, single phase, this entire thing and this entire thing. So pressure and temperature independent, so we are just calculating based upon this, okay, because this is entirely independent property. So for this we'll see the 10th chapter. I already explained, I'll just upload the video. So this is independent, this is independent, so this is generally independent, so we take according to the independent properties, okay. So chapter 4, okay, mass is given, okay, mass 3 kg, 3 bar, 27 degree, contain digit and insulated cylinder, not isolated, insulated cylinder. Parallel wheel work is done for 30 minutes at the rate of, okay, so work they have just given. So final temperature of the gas, they haven't given what type of process, okay, let us consider polytropic. Pedal wheel, okay, so mass is 3 kg, P1 is 3 bar, T1 is 27 degrees Celsius, so work is 0.015 kilowatt, but we need in kilojoule, so work into 30 minutes, so 1 minute equals 60 seconds into 60 seconds, so work is joule per second, so second gets cancelled and work is this one. See, okay, final temperature of the gas, okay, equal to W plus of delta U. Okay, this constant, okay, this one you can see C delta U is m CV of delta T, T2 minus of T1, okay. 0.015 into 30 into 60, this one will be the kilojoule, okay. Plus of m is 3, CV is 0.3122 kilojoule per kg Kelvin, okay, kg cancel, Kelvin cancel, T2 minus of T1, okay. Equal to 0. So I think so based upon this you can calculate. Okay, so temperature will be 3 to 8, okay, that's it. Okay, we can just go for next question. It's been asked in this one. So you can see 1 kg of diatomic gas, diatomic, okay, is heated, temperature, okay, energy added, here I see the specific heat, okay, so Q equal to W plus of delta U. Where energy added at constant pressure during, okay, constant pressure means change of enthalpy, so this is energy added Q, this is minus, so minus 500 equal to work W plus of m CV delta D 600 minus of 100 y it's been constant process during the constant percent during the process, so for that it will be 0. So minus 500 equal to m is how much? 1 kg. So into, so 500 will be of CV. So kilojoule per kg kelvin. Okay, I am just making the mistakes. Energy added at a constant percent during the process, work done on minus heat given plus check, so it will be 1. Oh my, add a chai. Oh, good question. So EF added equal to m Cp T2 minus of T1. Okay, so 5, so Cp will be 1 and gamma equal to Cp by Cv. So that's why I was thinking diatomic, I will write that. Okay, so Cv is Cp divided by gamma. Gamma is 1.4, 1 divided by 1.4. Cv you will be getting. Okay, this is a good question. So you can just go for this question. So a piston cylinder has initial mass third P1 0.1 CBR given P1 1.5 for T1 298 Kelvin. The pressure is moved to compress. Okay, P2 is what is submitted, T2 is 425. During the process 20 work is done. Okay, work done equal to minus 20 kilojoule. Q is how much? So Q equal to W of delta U. Okay, so here CVs are given. Change in internal energy, it means here closed system. Okay, whether a constant process given, no constant process, constant volume given, no constant volume, and insulator, no insulator. So polytropic process, maybe polytropic process. So what might be the answer? Change in internal energy equal to m Cp and Cv we can't take here, because Cv is, that means it should be constant volume. Cp we take means it's about constant pressure. So Q, okay, suppose Q equal to minus 20 kilojoule plus of change of internal energy, maybe what's it? Delta U is how much? M Cv T2 by T1 is. So M we need to, so P1 V1 equal to M or T1. Okay, so I think so C or everything is given, so calculate M will come at 10 kg and M Cv T2 by T1. So T2 T1 everything we know and Cv also known, M known, so put here and we can calculate the answer. Okay, that's it. That's an easy problem. I was taking so much longer. So okay, this will be the final question, fourth one. So a rigid adiabatic container has two parts, A and B, separated by a piston. Part A is essentially, this one is 1 kg, CV, okay, everything. So okay, everything. So part B is filled with 1 kg. Same ideal gas pressure is P2 is 2 bar. Is the temperature same? No, the temperature is not same. This is 600 Kelvin, this is 400 Kelvin. If temperature is same, we can just add the pressure. The business the final pressure will be P1 equal to V2. Just think what might be the answer. Mass PV equal to MRT. So volume we can just find volume 1 and volume 2. P1 V1 equal to P2 of V2. So volume will be same, okay. So volume equal to V1 plus of V2. So then final thing will be, for example, you can just assume like this. So P1 V1 MRT1 RT2 P, it means final pressure P3, volume total volume divided by MR, temperature will be also changing T3. So equate both, we will get the volume, but how we can just find the temperature? MRCV so here definitely delta U will come, okay. Delta U equal to, because you can see while we are just taking here, the internal will be same, okay. So MCV T2 minus of T1. So now you can calculate delta U. Okay. So next one, delta U equal to delta U final MCV T3 minus of T1. Or let us suppose like this one. Since you can see this one, delta U will be same, as delta U will be same. So MCV T final. So definitely the temperature one is 600 and this one. So T1 will be greater T final equal to MCV T final minus of T2, okay. So M is same, M same, M same, CV same, CV same, okay. 600 Kelvin minus of TF equal to, so TF minus of 400. So you can see 600 plus 400 2 times of TF. So TF will be 500 Kelvin. So P final V final equal to M R of T final. So volume will be so P1 is how much? 1 bar. V1 equal to P2 is how much? 2 bar of V2. V1 equal to 2 times of V2. So V is V1 plus of V2. So it is an understand. So P1 V1 MR T1, we can, from this V1 we can calculate and V2 also we can calculate, and both you need to add here, okay, and put here, and finally we can calculate. Wow. So you can see this one. So see, Wow, that's a good question in my point of view. Okay guys, then I'll just see you in the next video, and until then take care, bye bye, have a good day.